Hello, good evening, good afternoon everyone. Today inshallah we will make a quick revision. It's not a revision by the meaning of the word, but I will go through some of the main issues that you will find in our course. It's really very important. All of this are are handable for you and you can access it easily. First of all, there is some remarks I want you to put in mind while you are studying. Of course, most of our courses are dense enough that you are not going to be able to review it on the day of the exam. This is a horrible mistake. Don't do it. You have a full time, you have resources, you will have to go through it on a timely manner. This is why we have all the lectures recorded, and this is why you have a support from Moodle. This is really, very important. So, first of all, go through your slides. If I want to review for the final exam, it's going to be on Sunday. You're damn lucky. You have Thursday, you have Friday, you have Saturday. You have 3 days. 3 days, it means a total of 36 hours that you can build anything in them. So first of all, just to go quickly through your slides. You have the recorded lectures. You can review them if something you need to review or have a quick review for it. At this revision, you don't have to go through the multiplication of matrices number by number or so, because you already know about this. So in the slides that looks very nice for you and you remember them, don't waste your time and energy. So go through your slides one by one. Please resolve the examples to refresh your power and to maintain speed in multiplying the numbers and so on. The videos that we did together, recorded lectures, are not replacement of attending classes. This is very, very important. They usually say that for you. Number 2, go to Moodle after you finish. So I can't go to Moodle first to access quizzes or to access exams or midterms before studying. Okay, it's not good. So first of all, I will have to go through the slides, gather all the information in my mind. I've tried to solve some stuff. If I were in your shoe, I would do it today. I will do this task today. Just go home after we finish, take your meals, get enough sleep, then wake up very, very early or late at night and start doing the slides. Starting from tomorrow, start dealing with Moodle. Okay, go to Moodle to try to solve the quizzes after you study the ones that will be considered the one with the highest grades, so don't waste that. Okay. Number 3, do the assignments. It's really matter. I've sent you the assignments previously, so do them once more. Number 4, don't give up easily. I'm usually telling you that. I will have to review the slides. The most important part of the slides for us is to go through the propositions. We have, through our slides, we have a bunch of propositions. So when you go to multiplication, you will find some of the propositions already listed. You will have to go through them, those propositions of multiplication. When we went to inversion, how to get an inverse of a matrix, there were a bunch of propositions. Just to go through them. The transpose of a matrix, replacing rows into columns and vice versa. Go through those propositions. That's a place, if I want to ask you questions indirectly, this is the place that I'm going to ask you. So you will have to do this. Okay, and don't give up once more. Number 5, follow the updates on the WhatsApp. It's the link between us, it's the fastest. So if anything required, I will be there with you. Be in the campus earlier than your exam time. Your exam is going to be on Sunday. I believe it's going to be at 2. The room is 2, reserved for us. It's 201. It's going to be at 2, so please try to be inside the campus within maximum at 1 p.m. or at 1:30 p.m. if you are not going to come early in the morning. So just come easily, relieve yourselves. You should have very good sleep before the exam. It's not good that you come and you didn't sleep enough, because your mind is not going to work at the best when you are tired. Finally, best to you all. Okay, I would like to go with you through assignment number 4 in specific. It's really very, very nice assignment. We already did it, okay, previously, and we have the grades and everything, but I want to resolve it with you in details. If you look to this assignment, in specific assignment number 4, it was hunting, and I've sent you all the slides just in case if the letters are small or something. Okay? So, he's asking you about a linear transformation. And in the heading of this question, he gave you 3, as you can see, 3 transforms. The first is transforming from R2 into R2. And here is the transform. The second one is from R3 into R2. And that's the machine of the transform, or the function of the transform. And that's for the third one. So how many transforms do you have? 3 of them. Look to the questions, one by one. First of all, I will need to get the matrix of the transform, which is really very simple. I've explained it to you before we start. It's really very simple. So if you look to the first transform, it's moving from R2 into how many coordinates? 2. This is x plus y and the x minus y. So it's moving from R2 into R2. After transform, it is the number of rows of the transformation matrix. The input is the number of columns. So simply, it's a 2 by 2. Okay, I can do it very quickly. Row by row. So I will go 1, 1 for first row, then 1 minus 1 for the second one. That's the transformation matrix for T1. To get the transformation matrix for T2, it's exactly the same if you want to do it row by row. Also, it's going to be the same if you use the columns of the unit matrix. So here I'm moving from R3 into R2. So as you can see, I have 3 coordinates, and it will appear after transforming how many coordinates? 2 of them. Okay, very good. I can do it also row by row. The dimension of the transformation matrix. After the transform, how many coordinates? 2. And the input is? So I'm expecting the transformation matrix to be 2 by 3. 2 by 3. Okay, it's very simple. I trust. Okay, how to do it? This is x plus y, I'm missing z. For the second row, this is x minus y, I'm missing z. So it's very simple. The first row will be 1, 1 and 0. Second row will be 1 and 0. Here we go. That's the transformation matrix that moves the stuff from R3 into R2. Are you with me? Exactly the same for R3 into R2, but with another shape. He's going to move x, y, and z, and it will appear to you, x and y. Give me the first row, Ahmed. Look to the first row, 0, 0. And for the second row will be 0, 1, and 0. This is what you are going to see. So here is the transformation of the third. So first of all, he gave you the transformation, Ahmed. So the first step is to get the transformation matrices. I already have them. We will start the questions. The question is, what is the inverse of the transformation T1? Or which of the following is the transformation for T1? Okay, to do this, okay, he is asking you about the inverse of the transform. Very simple. How to get an inverse of the transform? Not all the transformations are invertible. The ones who are invertible, they have to be from the same dimension. So I'm moving from R2 into R2, or R3 into R3. Is this going to be invertible? No. Is this going to be invertible? No. The only one invertible is the first one, which is 2 by 2. Okay, to be invertible, Yafras, how to be sure that this transformation is invertible? By checking this matrix, if it has an inverse. Very, very simple. As we know, you have to evaluate the determinant of this matrix. 1 times -1 is -1, minus 1, so it's a -2. Does it equal to 0? It's an invertible. How to get an inverse for this matrix? You have plenty of rules. We had Gauss previously, and also we know about the practical rule that I told you about. Very simple. First of all, Omar, I will have to get the determinant, which will really be evaluated, which is -1. 1 times -1, and that's -1. So it's -2. So I will go -1 over 2. So the first step, in order to get the inverse for this matrix, it's going to be really, very simple. If I want to do it, let me turn the lights on. I will write it for you. It's really, very quick. So all I have to do is to evaluate. This is the main matrix. This is the linear transformation matrix. which is simply 1, 1, 1, negative 1. All I have to do is to evaluate the determinant. The determinant is negative 1 over 2. So it's a negative half. Open a new matrix. Replace the elements on the principal diagonal. Then change the sign of the secondary diagonal. The inverse in front of your eyes. Okay, it's gonna be, as you can see, very, very simple. It's gonna be a half, a half, a half, then negative half. Did it take time from you? Nothing. Okay, some of you already did it right. Okay, so that's the inverse of this transform, guys. How to get the shape of the inverse of transform? So, first of all, I was in R2. I've used this matrix to move into R2. If I want to get back, I will use this guy. So all I have to do is to multiply this one by x and y. And I will get the shape of the transform. And this is really very easy to do. All I have to do is the first equation. I will multiply this matrix. Here we go. This matrix, I will multiply by x and y. It will give me the function of the transform. So it's gonna be half x, half y, first coordinate. Second coordinate is gonna be half of x minus half of y. Which one of these alternatives? Which one of these alternatives? Yes, you are right. I will choose the last one. So that's the correct answer for this question. Okay, really very simple. And if you remark, we have measured a bunch of information about this. I will go for the second question. And he's telling you which statement is true. Is T2 is injective? Is T2? He's talking about the second transform. The second transform. Okay? The second transform, it is this guy. This is the transformation matrix. Is it injective, surjective, bijective, or none of the above? Once more, injectiveness means that the kernel will be in the 0 point. Surjective, it means the codomain, after you make your transformation, it represents all the R2 dimension if it is in R2. Okay, what's bijectiveness? Bijectiveness, it means your transformation is injective and surjective, which means it is invertible. So first of all, it's really simple. It's not going to be this guy. It's not going to be this guy. Why it's not going to be this guy? Because the matrix that you are dealing with is 2 by 3. How is it going to be invertible? So it's not going to be a bijective. Done. Okay, let's see T2. Here is T2. X, Y, and Z. It goes into x plus y, x minus y. That's the transformation matrix. If I want to do it, I want to check the origin of 0, 0. If I had the transform, which is x plus y, x minus y, I need to see the kernel, which appears in the origin. Okay, very simple. X plus y, x minus y. Once they equal to the origin of R2 is 0 and 0. So the first component should equal to 0, the second component should equal to 0. If you start with the second component, which means x equal to y, am I right? So if x equal to y, and then I will make the substitution, you will have x equal to negative y. How x at the same time will equal to y, and at the same time will equal to negative y is not going to be useful. So x plus y must equal to 0. But z is free. There is no z component here to appear in the origin. So does the kernel 0, 0, z such that z belongs to R? It's not going to be in the origin. Dimension of the kernel is equal to R. This is going to be actually much easier on us, as I told you previously, once we go through the dimension of the kernel and the basis and the vector spaces down the road. But for the time being, this is enough. For the surjectiveness, all I need to do, if it is surjective or not, to check if the dimension of the function after the transform contains R2. All the elements of R2, matrices of 2 by 2, Muhammad, matrices by 2 by 2, so the rank should be 2. If you look to the matrix of the transform of A, this A matrix, the matrix of the transform, and you try to evaluate the determinants -2, which means it has the same dimension. So the correct answer is surjective. The last question, it's more handable. The last question, it's more handable. He's telling you about the composition of the transform. I've already talked about this in the previous lecture. To have a composite transform, which is explained as the following. If I have an X over here, the first transform will move you to A of X. The second transform will move you to B, A of X. So actually, I'm moving stuff from, let's say, from R2 into R3. Then I will move again from R3 into R2. Do you read what I'm saying? So I need two transforms. I can do it all at once. How to do it all at once? I will go directly from X to B of X. How to do this? I will multiply the transformation matrix for the first transform times the transformation matrix for the second transform. So he's asking you now. This is from T1 into composite into to T2. So I will use the first transform to go to T1. T1 to go to T2. Okay? Then I will do that to the T2. So the first transform, if you look closely to the transforms T1, T2, and T3, T1 is moving stuff from R2, as I remember, into R2. The second transform, which transforms stuff from R3 into R2. So all I have to do is to multiply the transformation matrices. Let's look to the previous slide. Those are the matrices of transformation. This is T1 and that's T2 and that's T3. So if I have T1 composite T2, I will multiply these two matrices in each other. I will get the result. Multiply these two matrices in each other. Is it going to give you the third transform? Is it correct or not correct? If I want to transform from T1 out to composite T1, T3, so I will multiply these two matrices in each other and so on. Are you with me؟ شباب انتوا معايا؟ اوكي لذلك هنا كل اللي انا هعمله هاخد الماتريكس اوف linear transformation بتاع T1 I multiply it T2 is it going to give you the linear transformation matrix of T3? If yes, okay. If not, not. So I'm not going to choose it. And I will go through them one by one. One of them is the correct answer. Are you with me, Hasan? So it's a direct application on multiplication. Those are the questions of the assignment and they are really, as you can see, handled. The mock exam is a must. For those of you who didn't attend the mock exam, you will have to. The entrance word, okay, it is ready, okay, and I have shared that with you. Ready, set and go. Just enter it after you have your voice flow and you will enter the exam. And the quit word is 1, 2, 3, 9. Just in case, as I know you have some of you problems with voice flow because of your PCs. So this is why I thought it is better just to take print screens from them and put them to you just in case. But please try to do the mock exam because the questions are withdrawn from the question bank, so they may be different. But still, it's really very good. Okay. Let's see that. The first question, and the reason that I'm going in this with you is really very simple. It's not about how to answer the questions. It is about how to think in these questions. Okay, and please sleep well and have attention, full attention in your exam. Don't talk to your neighbors or don't be occupied in mind by anyhow. You will have enough time. The time is enough. So relieve yourself, start easily, and don't worry. Let's go through the first question. Okay, the first question states, suppose that for some matrix A, we have a matrix called A. He's giving you this guy times A equal that the result matrix. It's a question about multiplication. And he's asking you, Mr. Hazard, which one of these matrices is A? No. He's asking you, which cannot be A? Remember, which one is not a matrix. So let's think together. If I took this matrix and I put it here, try to multiply by your eyes. I will multiply the row by the column. So 1 times 1, what? 1 times 2 is 2. The sum is 3. That's the first number. Take the first row and multiply by the second number. By the second row. By the second column. So it's going to be 1 times 1, which is 1. 1 times -1 is -1. The sum is 0. So the first row is okay. Don't just trust the numbers with the first row. Do it for the whole of them. So if I try to do through the second or through the third, this is the correct one. So this could be A. I'm not going to choose it because he is asking me which one of them cannot be A. So please be careful about this nature, the nature of these questions. Because usually our nature will go with the right one. So if you choose it directly, it's not going to be good. It's not going to give the right answer. Okay, let's try the second one. If you try to put the second one instead of that one, okay, once more, multiply the first row by the first one, I'm going to give you 3. Multiply the first row by the second one, I'm going to give you 0. And the rest. So this is correct. Try the third one, it's also correct. But if you try the first one, let's multiply the first row by the first column. 1 times 3 plus 1 times 3. The total is this 6? No, stop. So that's the correct choice. The bottom line, it's very, very simple. As you can see, it's very simple, but it's also manipulating it. So this is why I thought to go with you with this one. This one also, it's really very simple, but it's tricky at the same time. So please be careful. He is asking you, which of the following matrices is a symmetric matrix? So this part is hunting the part of matrices. What's a symmetric matrix? The elements are symmetric around the principal diagonal. صح? Okay, let's see. That's one. He's asking you what is a symmetric matrix. This one is symmetric, but he added something. He also asking you about a symmetric matrix, but with a condition that the trace is equal to 4. Has it? What's the trace? The sum of the elements on the principal diagonal. Okay, this is correct. أحسن؟ إن شاء الله أحسن. Okay, بس إيه؟ ما تستسلمش. ماشي؟ إيه؟ طيب معلش. طبعا this is okay. لو أنا جيت على ده خلي بالك، لو جيت على ده اسمه سيمتريك فمش هختار أصلا. لو جيت على دي لا دي ولا دي. مش هختار. لو جيت على ده تنفع إنها تبقى إيه؟ سيمتريك. الإليمنتس سيمتريك أراوند بس التريس ما هواش بفور سو دي هتبقى الفيرست انسر الفيرست ماتريكس ده اكيوريت. اوكي تعالى بص لي على دي، اسالك على اللينير ترانسفورم. بص بقى على اللينير ترانسفورم، بيقول كونسيدر تو لينير ترانسفورمز اذا تي، يبقى عنده ترانسفورم اسمه اس، ترانسفورم اسمه تي. The matrix of the transform AS is giving you 2 by 3. طيب any one of you can tell me this is 3 by 2, so it's moving the stuff from where to where? This is 3 rows, 2 columns. Moving the stuff from where to where? The number of rows is the output. The number of rows is the output. The number of columns is the input. So it's moving from R2 into R3. But this guy, العكس بيموف من R3 into R2. Okay, very good. يبقى أنا عارف إن ده بيموف بيعمل إيه ده بيعمل إيه. Which is the expression that define the composition of the transformation? S composite mean. Any ideas أعمله إزاي؟ ما هو S composite دي معناه إنك هتضرب الترانسفورميشن ماتريكس بتاعت الإس في الترانسفورميشن ماتريكس بتاعت التي. طب هو ينفع؟ ينفع. ما هو ده 3 في 2 وده 3 في 2 وأنا آسف 2 في 3. يبقى إذا الريزلت هتبقى 3 by 3. يبقى أنا I'm expecting to see from those the ones with 3 coordinates. يبقى إذا ده لا. 1 2 ده ممكن. طيب هعمله إزاي؟ هاخد ال 2 matrices multiply them together which is gonna be simple. بعدين to compare the results. فاهمين معنى كلامي؟ يعني انا الاول هعمل مالتيبليكيشن، ضربت التو ماتريسز في بعض، طلعت لي الماتريكس 3 باي 3 معايا عمر قاعد. بعدين I will multiply till x, y and z and choose the correct answer. Are you with me? Okay. It's very very simple. Okay. تعالوا بص على ده drag and drop. يبقى انا هشوف الرايت انسر I will drag it او choose it. طيب هو بيقول ايه؟ طبعا it's andable. يعني still الكويستشن ده andable. معايا عمر؟ لان انا بيقول ايه؟ drag the right options in the answers correctly to the questions. طبعا انا متخيل ان ده in the camera and the recording it's not going to be very clear to you. But this is why I'm sending you with this one the PDF. Okay? So you already have the PDF. Okay, how to solve it? First of all, he's giving you a matrix 1, 1, 1, 1. And the other matrix is 8, 1, 3, and negative 3. So I will do the subtraction first, then I will do the transpose. He's asking you in specific about which is the value of 1 and 2 entry. So after you do this, evaluate row 1, column 2. The value of row 1, column 2. Okay? And choose it from these values. Which or what is the rank of the coefficient matrix? 1, negative 2, negative 1 and 2. How to do this? How to check the coefficient, the rank of the coefficient matrix? First, how to do it? First of all, get the coefficient matrix, which is a very simple task. The coefficient matrix is, if you look carefully to what's given, if you look carefully to the matrix, it's gonna be the matrix which is 1, negative 2, negative 1, and 2. Okay? To be sure about the rank, multiply the elements of the principal diagonal. 1 times 2, it's going to be 2. Minus positive 2. The result will be 0. So it's not going to be a 2 by 2. This matrix is not going to be a 2 by 2. So the rank is not going to be 2. Okay, try to reach an echelon form. Can you reach an echelon form? Very simple. I need the pivot to have zeros beneath it, which is very, very simple. Add the first row with the second row. 1 plus negative 1. Negative 2 plus 2 is? You have 1 row. So the rank is 1. So he is asking you, what is the rank of the coefficient matrix of this system? It's going to be 1. I will choose 1. The statement after that, which is the trace of the 2 by 2 elementary matrix associated to the elementary operation new row 2 is equal to the old row 2 minus 3 row 1. Okay, what's going to be the rank? Careful, he's not the rank, he's asking you, what is the trace? What is the trace of a 2 by 2 elementary matrix? So I should go and put an elementary matrix. I will solve it with you. It's very helpful. As I told you, all the questions are coming. So he's asking you, what is the trace? What's the trace? The sum of the elements of the principal diagonal. Okay, so I should have the matrix, and then I will get the sum of the elements of the principal diagonal. Okay, by a 2 by 2 elementary matrix. What's an elementary matrix? Ionic matrix, 2 by 2, and I will do one of the row operations. What are you going to do in this matrix? So, first of all, that's my unit matrix. This is my unit matrix. 1, 0, 0, and 1. I will do what? Oh, okay. Let's see the description. New row 2. So I will change row 2. How to change row 2? Is equal to the old one, the old row 2 minus 3 row 1, which means I will multiply the first row in negative 3 and I will add it to the last row. So multiplying and doing, it's going to be a negative 3 and 1. What's the trace? The trace of this matrix is 2. It's 1 plus 1. So I will choose the trace. What is the rank of the transformation matrix of an invertible linear transformation 2 by 2? Anyone? 2. It doesn't need any effort. Once more. What is the rank of the transformation matrix of an invertible. What do we mean about invertible? It has to be from R2 to R2, from R3 to R3. So keeping the ranks, keeping the same dimension. Okay, to be invertible. R2 into R2, so the rank will be 2. يبقى R2 مش يونت ماتريكس. لما تجيب الانفرس هيبقى برضه 2 by 2. ماشي؟ يبقى هو سألك على الرانك. The rank is the number of non-zero rows. As you can see, it's very, very handy. Okay, for this guy, this is a beautiful one. Okay? بص يا أحمد كده بيقول what can be the augmented matrix of a system of linear equation with a parameter alpha belongs to R, which is يعني which أي واحدة في دول augmented matrix. بيقول لك which is consistent inconsistent if alpha بتساوي كام؟ negative 2. وبرضه يبقى consistent لو الالفا بتساوي كام؟ ولما الالفا بتساوي negative 1 هيدي لك consistent independent. انا اسف and consistent independent otherwise. يعني هو دلوقتي بيسألك مستر فراس السيستمز اللي موجودة قدامك فيها الفا موجودة في بعض الأماكن، بس السيستم اللي أنا عايز أختاره هو السيستم اللي لو الالفا بتساوي نيجاتيف 2 ما يتحلش. لو الالفا بتساوي نيجاتيف 1 يدي لك انفينيت نمبر اوف سولوشنز. تمام كده؟ وبيدي لك أي قيمة ثانية الالفا will develop a unique solution. طيب تعالى كده واحدة. هاجي على أول ماتريكس شيل الالفا وحط نيجاتيف 2. لو شلت الالفا وحطيت نيجاتيف 2 هنا هيدي لك الرانك هنا الاثنين، والرانك بتاع الاوجمنتد ماتريكس بيساوي كام؟ يبقى ده هيدي لك انكونسيستنت سيستم، صح؟ يبقى اذا ايه؟ دي صح. طيب تعالى بقى شيل الالفا وحط مكانها كام؟ لو جيت اشيل الالفا وحط نيجاتيف 1 ده هيبقى رقم، هيبقى نمبر، بس الدور كله هيبقى بزيرو، ده مش بزيرو، يبقى انكونسيستنت مش انفينيت نمبر، يبقى ده رونج تشويس. تعال ننزل على التشويس اللي تحتيه. ايه؟ تاني انا هشيل اول حاجه الالفا احط كام؟ ده الفيرست تشيك. لو شلت الفا دي وحطيت نيجاتيف 2 ده هيبقى 0 0 0، بس النمبر ده مش بزيرو، يبقى الرانك بتاع الكوفيشنت ماتريكس بكام؟ بدون. يبقى الرانك بتاع الهول ماتريكس بكام؟ طالما الرانكات مش بتساوي بعضها يبقى نو سولوشن. يبقى اذا دي صح. تعالى بقى استخدم الشرط الثاني ان لو الالفا بتساوي نيجاتيف 1 السيستم ده يبقى ديبندنت، يعني الرانكات تساوي بعضها ماشي، وبالتالي هيديني ديبندنت سولوشن. تعالى لو جيت اشيل الفا واحط نيجاتيف 1 ده يبقى نيجاتيف 1 بلس 2 يساوي بوزيتيف 1، فالرو ده كامل مش هشيله. تعالى على السكند رو سالب 1 بلس 1 0 نيجاتيف 1 بلس 1 0 اصبحوا دول بزيروز وده ب 2، فلو جيت تبص على الرانكات هتلاقي ان الرانك بتاع الماتريكس الصغيره 2 لكن الماتريكس الكبيره كام؟ 3. يعني اذا لو الالفا بتساوي نيجاتيف 1 مش هيديك انكونسيستنت، فيبقى اذا الاولاني ده غلط. هروح شباب برضه على الثانيه وعلى الثالثه، بعدين تعالوا بص لي على اخر واحده. ايه؟ لو جيت احط نيجاتيف 2 هيجيب الصف الاخير ده كله دول بزيروز بس ده مش بزيرو، وبالتالي هيدي لك الرانكات انكونسيستنت. طب لو جيت احط نيجاتيف 1 هيديك السكند رو من البدايه للنهايه كله بكام؟ بزيروز. كده الرانك بتاع الصغيره الكوفيشنت ماتريكس يساوي الرانك بتاع الاوجمنتد ماتريكس يساوي 2 لده النمبر اوف فاريبلز هيدي لك كونسيستنت ديبندنت سولوشن. لو حطيت اي الفا ثانيه على طول ده مش هيروح وده مش هيجنه، فبيدي لك يونيك سولوشن. اتفضل.
هو زي اسمه ديبندنت
الديبندنت والاندبندنت. الديبندنت يعني infinite number of solutions. التو ranks equal to each other but less than the number of unknowns او number of rows. تمام؟ الاثنين زي بعض. تعال بقى بص كده، لو انا جيت ابص على number of variables او من 3
ما بحسبش اللي هي على خالص.
لا ده ماتريكس، ده ريزلتس، ده x1 x2 x3 ده ريزلتس. فيبقى اذا ده معناه ان انا عندي هاو ماني فاريبلز؟ 3. طيب لو انا جيت هنا واستخدمت نيجاتيف 2 لاحظ ايه اللي هيحصل؟ نيجاتيف 2 هيخليك الصغيره رانك 2 الكبيره رانك 3 فخلاص انكونسيستنت. لو استخدمت نيجاتيف 1 هيجي لك النمبر ده doesn't equal to 0 وبالتالي الرو ده not a zero row in both matrices فيبقى ده موجود معانا. الفيرست not a zero row يبقى كده how many non zero rows؟ 2. لو جيت احط نيجاتيف 1 in the second row كله يروح هيبقى ده 0 0 0 0 يبقى كده الرانك بتاع الماتريكس الصغيره والرانك بتاع الماتريكس الكبيره و how many number of variables؟ 3 يبقى infinite number of solutions. كمان نقطه عد الروز رو 1 رو 2 رو 3 عشان يديلك infinite number of solutions لازم يكون الرانك اصغر من عدد الروز المبدئيين. الماتريكس بقى بالبدايه كان how many rows؟ انت طلعتها برانك بكام؟ يبقى 2 لان 3 دي كانت
ده في الرانك بتاع
ده بالنسبه للرانكات وبالنسبه للروز وبالنسبه للانونز. طيب لو انا بتكلم بقى على الاندبندنت معناه ان التو رانكس الاندبندنت يعني يونيك سوليوشن التو رانكس الاول equal to each other وسيم تايم وات ذا سيم تايم equal to the number of variables. لذلك لو الفا doesn't equal to negative 2 or negative 1 the 3 rows will remain in both matrices وبالتالي هيبقى الرانك بتاعها بكام؟ ب 3 والنمبر اوف فاريبلز بكام؟ يبقى اذا على طول دي هتبقى ايه؟ inconsistent consistent independent system او consistent with only one solution.
انا لما اجيب الرانك او الكونسيستنت او الاندبندنت بجيبها في الريشنال فورم صح كده؟
اخر فورم
يوزد ولا ريشنال؟
الاشرون كافيه بس انا بحط اشرون صح. وطبعا لو جبت ريديوس ما هي اوكي. طيب هنا برضو السؤال ده مش بطال هو يديلك ماتريكس وبيسالك هنا الماتريكس ايه از نوع الماتريكس دي ايه بيسالك بعد كده يعني يا ترى الماتريكس دي بص على البرنسبل دايما بص النمبرز بتوعها ايه طبعا سيمتريك وابدا اختار فرق. السؤال ده بسيط مش محتاج برضه السؤال اللي بعديه ده مش بطال برضه بيسالك على الرانكس فانا برضه او سكيلت لكن عايز احله. هنا بيقول which matrix has خلي بالك يا حازم قوي بيقول which matrix مهند which matrix has rank equal to 2 ضروري قوي تخلي بالك من ده. خلي بالك وطبعا مش بسالك على الرانك انت محتاج تجيب مين؟ اشرب فور. طيب تعالى كده